Good afternoon, ladies and gentlemen, and welcome to AICT's initiative on quality subject-related talks. And today we are very proudly associated with one of the very prominent persons who join us from Rajasthan, Professor Mahesh Kumar Jat. A very warm welcome to you, sir.
Thank you.
Thank you, sir. Thanks a lot. I'm Colonel Venkat, Director, AICT New Delhi, and I take this pleasure and opportunity to welcome you and introduce you to the complete audience. Ladies and gentlemen, you would also be appreciating the effort that we try to connect the best people in the particular subject who speak or bring about their knowledge, their wisdom in front of you with a single reason and a single initiative that we propose our fellow faculty members to benefit from this talk. This is a talk which is being driven, which is faculty-oriented talks, which can be made use of and benefited by even the students, the research scholars, and why not, in case if some of us are from Industry Connect, that would be the ideal. If we can bring about an ecosystem of an educational related subject wherein all of us join hands together and move. So we are today joined by Professor Mahesh Kumar Jat from MNIT Jaipur. His qualification, ladies and gentlemen, runs phenomenal. Suffice to say the least, that he has done each and every qualification, he has each and every mandated attributes which he saw required to be in a faculty who then can be associated and then can be connected at a national level to many more faculty. So he's a role model in himself, and sir also has happened to have done his PhD from IIT Roorkee. And towards that, the topic today which sir is connecting happens to be geospatial data requirements, technological applications, options, and their applications. So without wasting any further time, I now request Professor Mahesh Kumar Jat, sir, to please address the gathering and do make us a little bit more wise on this subject. Over to you, sir.
Thank you. Thank you very much. First of all, good afternoon to all. And first of all, thank you very much to AICT for inviting me for this talk. Today I'm talking about the geospatial data and what are the different technological options which are available for capturing the geospatial data and their typical applications. So somewhat this talk is, I'm presenting an overview of the different, you can say, the gradual, you can say, the development in geospatial technologies from very conventional to the very high tech nowadays we people are using. And you see, the geospatial data, geo means I can say that I'm sharing my screen, and geo means, so hope you people are getting my presentation. So okay, I hope that you people are getting this. Okay, thank you. So geospatial, geo and spatial, there are the two terms. Geo means the earth surface, the spatial means the related to space. So just look at it. It means our lives is basically moving and on the surface, and we are dealing with the earth surface in every aspect of our life. Means we are facing a lot of, you can say, doing a lot of activities. We are experiencing a lot of phenomena, and all they are happening on the earth surface. And to very important thing is that all those activities and phenomena, they are interrelated. They have spatial relationships. One particular phenomena is a function of another phenomena, and they may be function of a space as well as time. So the geospatial means, geo means earth surface, spatial means related to location. So geospatial data means what are the information and data that is required about the different objects, different phenomena which are happening on the surface, above the surface, and below the surface. So that is spatial data. So conventionally, you can see that if we have a sufficient amount of data, accurate data, and if it is available at a required spatial temporal resolutions, okay, then we can deal with many decision makings more appropriately, and we can, you can say, make better decisions, okay, for different sort of problems which we are experiencing in our day-to-day life. So I can say that almost everything that happens somewhere. Knowing where something happens can critically important. Means look at it. Means each and every instant of time, number of things are happening at the different places, different locations over the surface, and these are interrelated. So space and the data related to space, data related to different objects and phenomena which are available, situated at locations, they are interrelated. So just imagine that how this geospatial data is important to deal with every aspect of our life, every aspect of different sort of problems, socioeconomic problems, engineering problems, we will face it. Okay, so basically imagine that and look at it from this statement. The importance of geospatial data is very much, you can say, evident. That it is published in Harvard Business Review that an organizational decisions increasingly become more data driven. Businesses need to assure decisions are made with most accurate data. It means for making optimum and better decisions, okay, your data should be appropriate in terms of resolutions, in terms of consistency, in terms of their accuracy. Okay, and that is very much important nowadays to make better decisions, optimal decisions. I'm not saying that so far what we were doing. So we were using, definitely we were using some data and information, but nowadays we becomes more efficient. Our decisions are more optimum, okay, more economical and more safer. So we are moving towards those sides, and by using the geospatial data and the technologies, we can reduce the uncertainties which were earlier available in your you can say decision making. So we are removing those uncertainties, we are reducing those uncertainties, and we are moving towards better decision making. So geospatial data to a common man, it basically it leads to the or translates directly to the locational information, and then further we can say the maps, because the geospatial data ultimately they are presented in the form of maps. So certainly these maps are very good to display of geospatial data. Okay, and everything we see has some kind of a spatial component. After all, everything everywhere we know some components of some data related to space. Where we live, where we experience different phenomena, okay, they are happening at somewhere in some point of time. The different activities, they are interrelated spatially. Okay, just like for example, how we travel, how we can make the decisions of least cost routes, how we can choose you can say the driving paths, how we can monitor the, you can say, travel time of transportation fleets, how we can incorporate the spatial and temporal variability of catchment characteristics into your hydrological phenomena, how we can deal with climate change and their related variables. So look at it. It means the example is numerous. Sometimes this information may not be involved directly, but sometimes it can help us indirectly in dealing with the different phenomena. So the geospatial data, it combines location information in terms of the coordinates. Okay, coordinates means reference location, and location is attribute information, means the characteristics of different objects and phenomena. They are called attribute information, and they are attached with the location, means the coordinates. And then often time also you can say attached with the location. So you can say the geospatial data is a three-dimensional information in the three-dimensional space, which is having characteristics of your objects and phenomena which are attached to the location. And time, you can say, also available, time step or time, you can say, space is also available with the data sets. So that is overall, you can define a geospatial data. And if you look at it, the requirements, nowadays, I can say with the confidence that nowadays, we people are more and more increasingly using geospatial data production and technologies for a variety of, you can say, engineering applications and non-engineering applications. Like in engineering, I belong to civil engineering background, so we can say that in civil engineering, all in planning and design of the different infrastructure projects, monitoring of different phenomena, like you can say the hydrological phenomena, basically natural disasters. Okay, in all aspects of operation and maintenance of different big infrastructure facilities and like facility management. So we use geospatial data. about the location and with the different objects, and different objects, a particular object may have thousands of different type of information. So the beauty with the geospatial data and their analytics is that the data, objects, and their characteristics, their relationship with other type of objects and phenomena, they can readily stored, they can be captured, stored, manipulated, and we can apply different sort of, you can say, analysis techniques on them, okay, to solve complex problems, to extract complex informations, to extract complex patterns, okay, and informations, abstracted informations, which is otherwise not possible with the help of conventional techniques. So this is a simple list of different areas. I just, you can say, important one that you can use in civil engineering, you can use in facility management, we can use in telecommunication also, like selecting the tower, telecommunication towers, their influence areas, okay, there we can investigate the shadow effects, okay, and a lot of other type of consumer data and the usage pattern with respect to space, how the different users in which locality, what is the density of users, and many more different type of anomalies, they can be extracted from geospatial data and related software and analysis techniques. Military, in the military also, like in target detections, okay, automatic object target detections, okay, monitoring of different strategic, you can say, assets, and then planning for the logistics, okay. So there are a lot of ways, okay, in which nowadays people are using geospatial data. In weather, like to deal with the natural disasters, like extreme events of rainfall, hurricane, storms, okay, we require a lot of geospatial data set, and look at it, because during the disasters, our conventional technologies of spatial data collection, they fails, means we cannot reach to the areas, but nowadays some advanced technologies, we can collect the data, we can monitor the situation, we can plan the rehabilitation, we can, you can say, evacuate the peoples, okay, and we can determine that how things are improving or worsening with respect to time. So these are the application of geospatial data. We can do the lot of, you can say, applications in urban planning. Nowadays, a lot of, you can say, zonal plans are developed, okay, like master planning, planning of cities, roadways, and you can say the utilities in urban areas, okay. So on all aspects of urban planning, nowadays people are using geospatial data, because everything what you are planning, whether you are planning the facilities or infrastructure, they are planned on the Earth surface, and their planning and the design is a function of Earth surface data, land use, type of soil, slope, metallurgical things. So in all those things, because they are related to location, and that's why the locational data is very, very important. And also it helps us, geospatial data, because your information is attached with locations. It helps us in incorporating the temporal and spatial phenomena. Okay, so natural resource exploration, like in natural, like forest management, forest monitoring, you can say exploration of natural resources like coal, okay, and water resources, land resources. So in all type of, you can say, monitoring, management, and collecting the data, making judicious decisions about their uses, okay, with respect to natural resources. In such applications, geospatial data things are very, very important, and nowadays no, you can say, solutions are developed without them. As I gave this an example related to disaster monitoring and management, of course, okay, nowadays, because these are very critical technologies, like in case of the floods, or you can say earthquakes or landslides, when we cannot reach to the road and we cannot use the conventional means of data collection, okay, some advanced geospatial technologies, they can help us in determining where what is happening. Like in hydrological applications in insurance sector, like recent example is agriculture, like Pradhan basically crop insurance scheme. So for a crop insurance, like we need to monitor what is the health of crop, what is if damages are taking place, what is the extent of damages, okay. So in these things also geospatial data is required. So look at it, means in many aspects of our lives, they are other applications are like in navigation. In navigation nowadays, we use mobiles to move from one place to another place. We drive cars, to find out the least, you can say, distance routes. We use trains, aeroplanes, so airplanes. In all these things, navigation is used. So look at it. It means nowadays we people are using every aspect, like your Zomato and Swiggy. They are supplying pizzas and food things. E-commerce companies, they are supplying with respect to location only. So look at it. So at all these center of these applications, okay, geospatial data is very important, and we people are using a diverse, you can say, technologies nowadays. Very fast, you can say, the improvements, or you can say advancements, are taking place in these technologies. So I am just giving you an overview about that what are the possible options are available, okay, technological options for geospatial data collection. Okay, so like geospatial data requirement, we need data for planning, urban planning, rural planning. We use for water resources facility planning and design, like for dams or reservoirs. Okay, you want to determine the capacity, water availability. For that, we have to essentially do the hydrological studies, and for all hydrological studies, because rainfall runoff phenomena, they are happening on the Earth's surface, and to determine the different components of hydrological cycle, we need the information about soil, we need topography, we need information about rains, we need information about different type of land use, land cover. So all these are nothing but data spatial, geospatial data things. Okay, like in design of infrastructure things, we require a lot of, you can say, geospatial data things. Okay, so look at it. Sometimes, and when you combine this geospatial data with the data analytics techniques like big data analytics, okay, nowadays a large volume of the data sets can be, you can say, can be used to identify the complex patterns, hidden informations, okay, the different type of, you can say, information with respect to distances, proximity, contiguity, okay, different type of association, a different variety of hidden, you can say, the information in the massive data sets, okay, that can help with the help of geospatial technologies by using the big data analytics on geospatial data, using data mining techniques, and we have a lot of different techniques nowadays available, and we people are generating a lot of solutions in this particular area. Okay, and why the geospatial data? Because you see, everything is, many of, you can say, part of our life, okay, they are location function dependent. Okay, there are certain locations are more critical as compared to other things with respect to infrastructure design, for road safety, landslides, floods. I'm just giving there some engineering phenomena, or like crime density, okay, disasters, popular travel destinations, okay, telecommunication. So you can see a variety of areas where the location is playing in a role in many decisions. That's why location is important. Why does a flood came more frequently at a particular place? Why groundwater is more polluted at a particular location? Okay, so location is everywhere. Okay, so that's why we need to understand the location and its influence on our decisions, human behaviors. Okay, and that's why the location and geospatial data is very, very important. For collection of, means there are two parts to use the geospatial information. First is a geospatial data collection, and second part is that analysis of the data using variety of techniques. So the geospatial data collection you can perform in two ways: either in situ data collection, that we can go into field and then collect the data, or second one is that we can collect the data remotely from variety of remote sensing techniques. And the data collection doesn't mean that simply data collection about different objects. No, a variety of biophysical information about different phenomena. Okay, phenomena like land use, land cover, throw-offs, vegetation, soil moisture, earth surface temperature, water quality in surface water bodies. Okay, variety of things, air pollution, the dispersion of air pollution, like forest fires, extent of natural disaster. So look at it, a variety of information that we want to collect. Okay, so remotely as well as in situ data collection, we can collect it. So just look at it. When you combine geospatial data, okay, with related mapping technologies, or you can say geospatial technologies, that is called geographical information sciences. Okay, okay, it is very, very useful. Okay, so allied geospatial technologies or analysis technologies, they are interaction models which depicts the relationship between geography, information sciences, and they relate with the mathematics, with the logical, you can say, things, and physical, biological, and social sciences. So nowadays, basically, we can develop the interaction models. We can develop model where GI, geography, and sciences can be, you can say, combined or integrated with variety of other type of, you can say, the phenomena, physical, biological, socio-economical, or mathematics, okay, to solve the different variety of problems. Okay, then geodesy and surveying, they provides us the horizontal control and vertical control, means they gives us the referenced information with respect to on a whole Earth surface, that we can relate different points on the surface. Okay, then cartographers map geospatial information, okay, and GIS, they are used for model geospatial information. That is, we can nowadays use GIS everywhere. Okay, you can just give the name of any you can say department or project wherever we are not using GIS. Okay, and nowadays even we are using for the crime analysis, we are using GIS. Okay, in railways, in infrastructure planning, everywhere, like in everywhere people are using GIS nowadays. Okay, satellites and suborbital platforms, means from the remote sensing systems, we can you can say extract the variety of information. Okay, okay, so so you can collect the data from remote sensing, you can use the GIS, we can use the cartography, we can use geodesy to provide a control, and we can integrate all these geographical information sciences with the geospatial data for the solution of variety of problems, which are maybe physical, biological, or social sciences related problems. So now I'm just going through briefly with the different type of technological options. So this was the discussion that I was trying to emphasize, that what is relevance and what are the requirements of geospatial data, okay, for the different type of, you can say, problem solutions. Now I'm just coming to the different technologies. So geospatial data collection part is first one. So the traditional technologies that we all are aware about it, because we used somewhere, sometime, okay, one or another technologies for obtaining the data related to our surface, in determining the distances, directions, position on our surface, okay, and determining position on a maps, or sometimes to prepare maps, we need to collect the data from the field. Okay, so these are the things basically, okay, which were earlier used to collect from conventional surveying techniques. Okay, so now basically the conventional technologies are like surveying. So first one is conventional surveying techniques, and conventional surveying techniques are there, that is nothing but the art and science of determining the relative position of various points or stations on the surface of the earth by measuring the horizontal and vertical distances, angles, and taking the details of these points by preparing a map or plan to any suitable scale. Okay, so that is what called surveying, and the surveying technique is conventionally we are using to prepare maps, a variety of maps like topographic maps, cadastral maps, okay, and in planning and design of infrastructure facilities like roads, dams, railway sections, because you need to plan on the surface, we need to determine the earthwork calculations, we need to determine the elevation things, that at what elevation we need to keep our designs, and many more things. Okay, so the conventional surveying, the data is collected in the field, and that data is converted into maps. So different type of maps, okay, are prepared from conventionally, you can see, data collection techniques, like you can prepare topographic maps. Nowadays also from the advanced technologies also we can prepare such maps. And in our country, the Survey of India is the authorized agency which is basically mandated to prepare the different type of topographical maps, or different type of maps of our country, okay, and to establish the horizontal and control over our whole Earth, you can say the country, and they can provide us especially referenced information about the different locations. Okay, so nowadays also from the advanced technologies also we can prepare these maps. But the difference is again the time required and the accuracy by which we are able to do nowadays. Okay, that is the difference. We can prepare a lot of engineering maps like contour maps, archaeological maps, in the military applications, okay, geological maps, okay, you can use it for mine surveys, okay. So these are typical, you can say, the applications of conventional, you can say, techniques. And in conventional techniques, we people are using different sort of equipments, and these equipments are nothing but small equipments, okay, for chains, and we'll be discussing in coming slides, okay. So what is difference between there's a difference between surveying, plane surveying, geodetic surveying. Plane surveying was basically earlier we used to do for smaller areas, okay, when the Earth's curvature is not, you can say, making any influence or significant in planimetric accuracies, okay. But for large scale applications, okay, we have to consider the curvature effect of our surface, okay, and that's why that is called geodetic surveying, okay. So a variety of, you can say, geospatial data collection analysis techniques are available. I'm just made a list of it, like conventional surveying techniques, what we are discussing, electronic distance and direction measurement techniques, satellite-based positioning technique solutions, okay, remote sensing technologies, and that is remote satellite-based, or you can say aerial platform-based or ground-based. Then a variety of IoTs, Internet of Things, and sensor-based technologies. Then laser-based spatial data collection technologies, Lidar, unmanned aerial vehicles, drones, okay, ground penetrating radar, terrestrial laser scanners. Okay, so these are the typical data collection techniques. Okay, and then we have variety of image processing techniques, target detection techniques, image processing solutions, where these geospatial data sets which are collected from different platforms, they can be integrated. Okay, they can be, you can say, their errors can be removed. Okay, they can be processed. Okay, to extract a variety of informations. And then GIS, where the variety of data, okay, that is collected from diverse sources in diverse formats, okay, and that all those things can be brought down to a common standard in digital format that we can do in GIS. And then we can use the variety of data analytics techniques in GIS, okay, for analyzing the data to extract variety of, you can say, informations, and for the solution of different problems what we have discussed so far. A variety of problems can be solved using those techniques. So the conventional technologies which were used to prepare maps, they are like measuring distances, okay, using tapes and chains, okay. It's still like in revenue people are using such chains, but they have limited like accuracy, and their list count is large. So nowadays for precise work people are not using it. Okay, nowadays people are using electronic distance measurement devices or laser-based devices for measuring the distances. Then for measurement of directions, conventionally we were using compass for direction, but nowadays we have more precise equipments. For mapping, conventionally for mapping, we are using plane table surveying tools. Okay. Then for directions and angles, we were using theodolites, a variety of theodolites nowadays. Of course, in modern equipments as well, their basic fundamental principle is remain same, but we have automated the processes. We have enhanced the capabilities of sighting. We enhanced the capability of recording of minor instruments. We have reduced the chances of personal biasness. We have reduced the chances of errors, personal errors during data capturing. Okay, so the total stations, they are, you can say, developed, they are converted into electronic, you can say, satellites, then EDMs, then totalization. So that is progression of you can say these instruments in more and more advanced stages. Nowadays we have robotic totalizations that you can plan the operations, and you can single person can do the surveying just by placing a robotic totalization at a station, and simply you can move here and there with a target automatically it can you can say follow you, and you can capture the data in X, Y, and Z, and it can calculate, give you the direct coordinates. So this is gradual, you can say, progress we have made in the geospatial data collection techniques. Okay, so nowadays these techniques like the chain survey or plantable or leveling with the conventional leveling tools in theodolite, they are almost obsolete. Okay, we people are nowadays using more advanced equipments, okay, for measurement of X, Y, Z distances, directions, and levels. Okay, we can use the photogrammetry. Earlier we used to make the measurements from photographs. Okay, and that science is called photogrammetry, and the photographs can be captured from a variety of means, and then we can extract some information from the photographs. Okay, so the science of making measurements from the photographs is photogrammetry. Okay, so that is the next stage of, you can say, development of geospatial data collection after conventional technologies. So this is the one example of EDM, that theodolite. Nowadays we are measuring distances using electronic distance measurement devices like EDM and total stations. Okay, but look at it. All these technologies, while collecting the databases, they have some limitations. Okay, like these are, you can say, require a lot of time to capture data. Like for capturing the data of a small area, even we require larger manpower, more time is required. Like if you want to prepare, say built a position of a city, and you need every year to, so for surveying of a one particular whole city using conventional you can say means, it requires months of time, many months of time. Okay, so these technologies are time consuming, of course, and they have more chances of personal biasness in selection of instrument, in making a selection of type of measurements. So personal biasness may be there in your data, and they are not suitable for capturing of the data of very large areas in relatively less time. They are not efficient for repetitive information capturing. Okay, they are not suitable for inaccessible areas. Okay, these technologies cannot collect the data in night. Okay, because they require line of sight. Okay, so they are not suitable. Okay, for during the night time. Okay, and they have the limitations in terms of resolution and accuracy. Okay, they are more labor intensive. Okay, and of course they have limitations as far as the accuracy is concerned. So these are typical limitations, and this was the motivation for us to develop more newer and advanced technologies. And the new and more advanced technologies is nowadays we people are using it in somewhat unconventional ways, like, and these are nothing but satellite based positioning solutions. Nowadays we are using satellite based positioning solutions, like in your mobiles, we are searching our position using Google Maps. So on Google Map, when you on a location, okay, somewhat you can get where you are studying and how you are moving. So that is the, you can say, the solution that is obtained from satellite based positioning solutions. Like all your navigation systems working in your cars, mobile phones, on which Swiggy, on Zomato or e-commerce is working, all they are based on satellite-based positioning solutions. Of course, a variety of, you can say, techniques are available, which provides us the geospatial data and information. Hello. So I hope you people are getting my voice. Okay, thank you. Okay, so satellite-based position solutions. So basically, nowadays this is the upcoming technologies, and we have started their use. And just imagine that this is so fast. We people are using these technologies, and you will surprised to know that the overall positioning was, you can say, started. The first system, satellite-based positioning solution, becomes operational in 1993-94. Okay, and at that time it was conceived as a military application. Nobody was have thought in mind at that time that it was developed for civilian applications. But as and when it was basically released, okay, billions of dollars, or you can say numerous different applications are developed, and more peoples and organizations, they started using it. And so now this becomes a public, you can say, use based solution. Military is one side, and in public domain, okay, a lot of, you can say, market has been developed from the satellite based positioning solutions. And the versatility of the satellite based positioning is that nowadays almost all type of conventional techniques, and I can say with the confidence that even local stations, they are going to be obsolete in coming few years. Okay, and nowadays even you can determine the very accurate position, okay, from the satellite based positionings, just like in millimeter accuracy. Okay, even you can on the fly, you can develop maps, okay, with the help of these satellite based technologies. Okay, so name of the technology is GNSS, Global Navigation Satellite System, and we people are knowing this with the name of GPS. So GPS was a trade name basically about GNSS system that is developed by the US Army. Its earlier name was Navstar. Okay, however, it was later on, it was named as Global Positioning System, GPS. So GPS is a type of GNSS system, okay, that is developed by the US, okay, and looking at their application, huge market and the number of applications, okay, a lot of countries and consortiums, they came forward, and nowadays they have developed a lot of systems, because developing such a system is not easy. It is very complex. It requires very sophisticated technologies, and of course cost intensive as well. So that's why the only presently there are 4 full-fledged GNS systems are working in the world. Okay, and the first one was GPS, that is developed by the US. Another is developed by the European Union, that is Galileo. And another, you can say, GNS system that is developed and operation is in place, that is GLONASS by the Russia. And one is system that is developed by the China, that is Baidu. In addition to these GNS systems, which are applicable and they providing us their positional solutions worldwide, okay, there are the local systems are also available. Just like India, wide area augmentation systems, like our country has also developed basically vast system, okay, and its name is Indian Regional Navigation Satellite System. Okay, its name is also Gagan. Okay, so for Southeast Asia, we have developed our own, you can say, regional or wide area augmentation system, okay, which provides us a precise solution, and it reduces our dependency on other type of, you can say, GNS systems. Okay, so these systems, they gives us accuracy in millimeter, from millimeter accuracy to kilometers. Okay, and they provide us the information, you can say, positional information over the whole earth 24/7. Okay, so there is no, you can say, problem of now inaccessibility or weather, or you can say night. Here you can get the data at any time, 24/7. So the GNS is nothing but basically it's a satellite system. Okay, a system of satellite is launched in such a way that the whole earth is covered by the satellites, and these satellites, they rotate in the predefined orbits. So we know their position in their orbits at each instant of time. And then we have developed certain you can say receivers, you can say equipments, that is called receivers. Okay, those receivers are with the users. When users switch on that receiver, basically it starts receiving the signals from the satellites which are orbiting Earth's surface. Okay, and we have developed the software, and using the conventional surveying technique of triangulation, we triangulate the distances from the multiple satellites, and using those distances, we are able to calculate the position of a person who is having in hand it's basically receiver. So how it basically helps us to calculate the position on our surface. But mind it is a tool that means anybody can measure the distance on any place. Okay, so that's why initially it was planned as a military solution. And you're surprised to know that in Iraq war in 1991, because the development of first GNS system was started in 1978, okay, and it was almost operational during Iraq war time. So US military has used it very extensively during Iraq war for targeting the basically targets, okay. They fitted their missiles are having the GPS systems, and they are pinpointingly they are targeting the different, you can say, the locations. And in 1993 they released it, okay, and later on other type of systems are in place. So these are the different, you can see, systems, GNS systems which are in use: GPS, Galileo, GLONASS, and the Baidu from the China. Some other are in pipeline where you can get the data. GNS system or satellite-based positioning solution have three components. Okay, and these components are like a space segment, okay, which is nothing but a constellation of satellites around the surface. The ground control, you can say, segment, which have worldwide, there are a number of ground monitoring stations, okay, which constantly monitor these satellites. They are orbiting in the space, okay. They monitor their orbits, they apply their corrections, they receive the signals, they pass the instructions, okay. So they maintain it. That is done by the ground control segment. And a user segment is nothing but like your mobile devices. We have receivers, okay, variety of receivers depending upon the different applications. Okay, so those receivers are used, okay, to track the signals from these satellites, and we can determine position, we can map, or we can you can say prepare maps directly. Nowadays in the mapping mode, okay, even just like if you want to prepare a road map of Delhi, so simply you can fix a receiver in a moving car. The while car is moving along the roads, automatically a map will be prepared, and in the end of the day you can have a direct map of road map of Delhi. So that is a mapping mode. You can basically map the objects, you can map the linear features, you can map the polygons areas directly, okay, in real time, even using the GNSS receivers. Okay, so elements in the receivers, as I said, that's the space segment, the satellites, control segments, monitoring stations, and the user segment where the users are using this information. Okay, these are the type of receivers that are available. Sometimes very sophisticated receivers are available, and these receivers can be fitted on any type of vehicle, okay, and even in your mobiles, in tablets, okay, where you can do the directly mapping, you can collect the data, okay, you can prepare the GIS maps directly using these things. So this is the new advancement, means from the conventional surveying of you can say measuring distance, direction, or calculating the position. Here using GNSS we can calculate position in real world coordinates about any earth, any point on the surface. You can map areas, you can map roads, railway lines, you can map. So all mapping, positioning, and surveying, they becomes one point solution, that is satellite positioning solution. And mind it, their accuracy is nowadays very fast. Even you can achieve using suitable equipments and even some method, you can reach the accuracy of up to the millimeters. Even nowadays, you can do the layout of buildings, you can do the layout of roadways, you can do the layout of tunnels. I think I am receiving the message that slides are not changing. Of course, slides are changing. Please, I am changing slides. So I think you can log out and log in again so that your slides can work. I hope that presentation is reaching to all. Okay, so these are the solutions. Then so applications of GNSS technologies, their location, we can use these GNSS technologies for location, determining the position, for navigation, okay, getting from one location to another location. You can track objects, okay, you can monitor the personal movement or movement of vehicles, movement of any object, okay. Then you can use it for mapping. As I just given the example of mapping, you can determine the precise timing, because these satellites, and they have the atomic clocks, so they give us X, Y, Z, and time, 4-dimensional information. We can get it from GNSS. Okay, so this is the solution nowadays. Okay, and in coming days, we people are using the GNSS, you can say, solutions only for all type of geospatial data collection, and the conventional techniques, they are going to be obsolete. Okay, why GNSS? I mean, you can see that almost all limitations of conventional technologies, they are not here. Like, it doesn't require any line of sight, so you can work in inaccessible areas. It gives high geodetic accuracy, means automatically it considers the curvature of a surface, so your planimetric measurements are very accurate. Okay, and you can collect the data in a relatively less time. Okay, and you can collect the data of very large areas very fast, so this is economical. Okay, it is giving you the information in generalized coordinate system, where you can relate one point with another point on the surface you can say very easily. We can relate one point on the India with the another point in US or some other country, because it is giving us the information in generalized coordinate system coordinates. Okay, and this is relatively for larger areas and larger data collection, this is cheaper as compared to conventional technologies. Okay, how it works? It works on a basic you could say triangulation. Okay, and to determine the position of a particular point on the surface, we require measurements from the 3 or more satellites. So like GPS have the GPS GNS system, it have minimum 24 satellites at a time throughout the surface. And if you are standing anywhere in the world, you will be getting signals of at least more than 4 satellites. And nowadays more constellations are in place, so you can have the signals of satellites of GPS, Galileo, GLONASS, so your readings are more and more accurate. So so basically how it works, because these satellites, they are rotating predefined you can say orbits, so we know their exact location at each instant of time. Okay, and they emit radio signals. Okay, so constantly they are emitting radio signals, and these radio signals are unique from each and every satellite. So your receivers are programmed in such a way that they identify a particular type of radio signal from a particular satellite. So as and when you switch on your receiver, it starts getting signals from different satellites, and it matches the radio signal that is emitted from the satellite with the similar sort of you can see signal that is generated by receiver, and by mapping of these two signals at time lag. Okay, it can be determined, because your signals from satellite, it requires some time to reach to the ground. Okay, so that time difference, by matching the you can say by matching the you can say signals of satellite and signals of the receiver, we can determine the time delay in signal, and that time delay is nothing but the time of traveling of radio signals from satellite to the receiver. So that time multiplied by speed of light, that is 3 into 10 to the power 8 meter per second, gives us the distance between satellite and a receiver. Receiver kahan pe hai? That is at the ground in the hand of a user. So when we are able to get the distance from multiple satellites, then mathematically we can triangulate, and using the triangulation, once knowing the distances of the triangle from one common point to multiple non-points, whose coordinates in their orbit is known, okay, we can calculate the position of point on the ground. Okay, so that is like these are the distances calculated from multiple satellites, and these circles, wherever these 3 circles are intersected like this in the 3, so this dot is the position on the surface. Okay, so this is a simple method principle by which we determine the position, and these are the different you can say the possible applications of GNSS technologies. like you can do a lot of mapping applications or surveying for the infrastructure projects. Okay, you can determine the position in the field. Okay, you can do the mapping directly in the field. You can generate map. Okay, you can collect the data in dynamic mode, like you can put a receiver in any car or a scooter or in your pocket. While you are moving, you are collecting the data sets. So these are the typical application of Gnss technologies. Like this is a typical example of how the data about the different points and the different pathway, different areas can be collected from this. Even nowadays, through the softwares which are installed in your receivers, we can process in the real time, like the data, whenever your data are getting, the software is processing and you are getting directly outputs. So in the real time processing is possible. We are using them in navigation, in your cars. We are using in aeroplanes and trains. Everywhere the satellite-based positioning solutions are used. And these are the augmentation systems. Okay, different countries, okay, to strengthen the signals in their country area, they have developed, like our country has developed Gagan. Okay, similarly, different countries, they have local systems so that the signals of these GNSS systems, they can be strengthened and their accuracy can be increased. Because all these, you can say, constellations, they are giving us, you can say, signals in civil domain. They are not so accurate. Okay, signals for military applications, they are different, and the signals which are available for the public domain, okay, they are different. Okay, so the public domain signals, they can be strengthened by local area augmentation systems, and we have developed this Gagan. Okay, this is developed by our country. Okay, that you can say strengthen the signals in this part, this red area. So this is developed by our country, so we can have the satellites to measure the position within this particular part of the world. And these are other type of local augmentation systems like Gnss in Europe, WAS in the US, and MAS in basically in Japan and around surroundings. Okay, so these are the typicals. Of course, the measurements from the GNSS, they are not error-free, because your technology is based on the radio waves, and always radio waves may have some interference from the climate, from you can say topographical features, different type of gases and molecules available in atmosphere. So somewhat error may be introduced, but nowadays the multi-frequency, you can say, GNSS receivers are developed, and we have developed different methods which can be used to obtain the very precise measurements. Okay, so this is the upcoming technology for positioning solutions. Then another one is remote sensing, and many people know this remote sensing because remote sensing was started in 1972, and our country is very advanced as far as remote sensing is concerned. We are in top 5 countries in the world. Okay, and we can say with the proud that our remote sensing program is very robust and very versatile. So remote sensing nowadays is in you can say dispensable for many areas. Nowadays, we people are using remote sensing data everywhere. Okay, for variety of, you can say, application. So remote sensing data is nothing but a simple. It is not a photograph or image. Okay, because it is basically having information about some, you can say, interaction of radiations with the Earth's surface matter, and that interaction in terms of reflected amount of radiation, it is recorded, and that, you can say, that information can be used to extract a variety of information, biophysical information about the different phenomena. So this is not a simple mapping tool. So as I said, that remote sensing, either in the through the different sensors, scanners or cameras, and when these are sensors, cameras, scanners, when they are placed on the different platforms, okay, we can measure the variation, acoustic waves, we can measure the variation force distributions like gravity, and we can measure the reflected part of electromagnetic radiations, okay, to capture the different sort of information. So in the remote sensing, we use this electromagnetic radiations, because when the radiation, they are incidented from the sun, okay, they travel through the atmosphere, they are a particular radiation, these radiation in a particular wavelength, not in all wavelength. In particular wavelength, they are reaching to the ground, and these radiations are interacting with the Earth surface matter, and the interaction is taking place in the term of either these radiations are absorbed or transmitted or reflected back. So the amount of energy that is reflected from a particular surface or some particular object is a function of its chemical characteristics, its physical characteristics, and its location on the ground. So if any object or any phenomena is different chemically, biologically, or surface characteristics wise, okay, it bound to reflect different amount of radiation. And we design these sensors in such a way that we try to measure, we try to capture these reflected amount of radiation from the different objects. Since these reflected radiations are different from the different objects, so by that difference we can differentiate or we can identify different sort of object and phenomena on these images which are captured from the satellites. So that is, it means this is not a simple photograph. Okay, we are capturing the reflected part of radiation, and that radiation is a function of physiochemical characteristics of different objects and phenomena. And with respect to difference in these recorded reflectances, we can differentiate, we can detect, and we can measure the different type of objects and phenomena on these satellite images. Okay, so energy, we are measuring, making measurements. Okay, we are doing capturing the geospatial data in terms of reflected radiations, electromagnetic radiations. This is the spectrum, solar spectrum, and remote sensing instruments are designed to capture the reflected part of radiation of a particular wavelength. Particular wavelength, not all the wavelength. Like these X-rays, gammas, ultraviolet, they are very harmful rays, and all these are basically absorbed in the atmosphere. Our atmosphere is particularly favorable, and it allows a particular wavelength radiations on the ground, like visible portion. Visible portion of radiation, the small wavelength range from 0.4 micrometer to 0.65 micrometer. So this is the range that is called visible range, and our eyes are sensitive to this range only. So your atmosphere is particularly very transmissive within this particular range. So most of, you can say, passive remote sensing, you can say, systems, they are designed to capture the data in visible portion of the spectrum. Means your system is able to capture the data of different wavelength in visible spectrum. So a particular wavelength is called one band. So means remote sensing instruments, they are designed to capture the reflected radiations into these different wavelength bands. Okay, and these are visible portion, infrared, thermal infrared, and microwave. Okay, so these are the remote sensing suitable, you can say, wavelength regions in which generally we capture the data. And to capture the data, there are two types of, we are using sensors. Either sensors are their cameras and scanners, and these sensors are mounted on you can say certain platforms. Just like imagine that our eyes, if we are standing like in front, and through our eyes we are just observing different phenomena. Okay, like in front of my eyes, like I'm looking at your screen. Okay, and in my room I am looking at the window. So how I am able to visualize these things? How? Because my eyes are acting just like a sensor, and these sensors are mounted on a platform. My body is a platform in the head. Okay, and these eyes are nothing but they are recording, they are capturing, they're basically reflected radiations. These radiations are coming up from the sun, like in the night. Okay, we cannot see anything because we don't have the reflected radiations. So our eyes are acting as a sensors. They are mounted on a platform, and depending upon the height of my platform, my area in front of my eyes will increase. Okay, like putting a camera on a tripod stand. So your stand is a platform, your camera is a sensor. Similarly, when you put a scanner or sensor on a moving aircraft, okay, then your aircraft is a platform and that is your sensor. So similarly, to basically capture the data, repetitive data of a surface, okay, we have developed more sophisticated sensors and scanners, and those sensor scanners, they are mounted on moving satellites, because we can launch the satellites rotated at larger height. Okay, they rotate at a larger height. Okay, and so their ground coverage is very large. So you can see that scanners and sensors, they are mounted on these platforms like satellites, and then satellites rotate around the Earth surface, and while it is rotating, your sensor is continuously capturing the data of Earth surface. Okay, so in this particular fashion, okay, we are able to capture the data of whole Earth surface. And mind it, these remote sensing satellites, they rotate in geosynchronous orbit. Okay, like our Earth is rotate about the basically poles along the axis. Okay, so these satellites, they rotate in the polar orbit, around the near polar orbit. So Earth rotates west to east. Okay, and and they rotate perpendicular to your equator, sort of perpendicular to equator. So when a particular satellite completes one revolution around the surface, okay, by the time, like in around 100 minutes, a satellite completes one revolution around the Earth's surface. So when it rotates, okay, a new area will be below the satellite. So new in the next round or next rotation, it will capture the data of another area on the surface. And by these successive rotations around the Earth's surface, your satellites are able to capture the data of whole Earth surface. And that thing is going on repetitive. So mind it, that the limitation of conventional data techniques, that they were not efficient in repetitive data capturing. But here, this is the solution, that for a very larger areas, we can capture the data repetitively using the remote sensing things. Okay, so these are this is the part of, or you can system of remote sensing. So it uses the electronic radiations which are emitted from the sun in passive systems, and in active systems we use the radars, because in the radars they have their own source of energy, and that they emit the energy, and the reflected part is sensed again. So that is called active remote sensing instruments. And the systems which are using the basically their own source, they are called active, and the systems which are using sun as a source of energy, they are called passive systems. So source of energy, then from the source, radiations are incidented. Okay, then in between the atmosphere is there, where these radiations are interacting. Okay, a lot of radiations are absorbed in the atmosphere, like all UVs, ultraviolets, X-rays, gammas, all they are absorbed in atmosphere. But your radiation in the visible portion, it is going down, and here the radiation, they are interacting with our surface objects and matter, and one part of this incoming radiation is reflected back. Again, this is passing through the atmosphere, it is reaching to the sensors, and these sensors capture this radiation. So essentially, your sensor is capturing that what is reflected part of these radiations from each location on ground. Okay, so as and when it rotates, it captures the information from the different parts of you can say location on the surface. And the relative difference of this reflected radiation is nothing but is the basic source of information by which we are able to capture the information about the different objects and phenomena. So mind it, the reflectance will be different for the different objects. Like suppose to open ground, if your soil is dry and soil is wet, or it has moisture, your reflectance will be different. So look at it, by this difference only we can differentiate what is the soil moisture content in the soil. So in this particular, just giving the example that in this particular fashion, in terms of these large differences in reflected radiations, we are able to capture the information about the different biophysical phenomena, which is otherwise not possible from these things. So these are the different platforms in remote sensing: satellites, aeroplanes, balloons, camera stands, platforms, helicopters. Okay, so all you can mount the sensor on these platforms, and we can capture the data from you can say different location. What the difference is that as we increase the height, okay, your ground coverage will increase. Okay, your ground coverage will increase. So that's why nowadays your satellite-based positioning, satellite-based remote sensing is more popular, because we have large number of satellites. Their specifications are different. They are rotating around the surface, and you can get the data at any desired time interval, and repeated information can be get. Also from the satellites, they are designed, the sensors are so powerful nowadays that if you are standing on the ground, from these satellites, even you can count the number of people who are standing on the ground. So such a large accuracy means your resolution in public domain nowadays is from 25 centimeter resolution to kilometer resolution. You can get the data from satellites. So just imagine that how much and how fast you can capture the you can say information about the Earth surface using these satellites. So that's why it is very much popular. And because why again they are popular, because we have many options, different applications, they require different data sets. So now we have different remote sensing satellite and sensors which capture data in a particular set of conditions with a particular sensor characteristics, and they are suitable for a particular application. Like for cartographic application, for urban applications, you require high resolution data sets, but for forest mapping, okay, you require different sort of satellite. For a forest fire, you require different resolutions. A kilometer resolution is fine. So that's why we have many solutions, many you can say options are available that helps us in basically getting the data. Okay, then these are the ground-based data collection, that spectrometers can be used to collect the reflectance from the ground, and we use them for on-board, you can say, sensor calibrations. Then these are the different type of platforms, okay, from where we can get the data. And these are the data sets. Just look at it. This is a live map. Just look at it, this image. This is a live map because this image is available in coordinates. Generalized coordinate and position system means you can put any mouse cursor, you can get the coordinate of that location. Also, these colors are nothing but a 3-band data that is fused together corresponding to 3 primary color, okay, that is called false color composite. So color image is prepared from the remote sensing data of 3 wavelength bands. So we have reflectance in 3 bands. So it means even with the help of the differences in reflectance, we can determine the different objects. And this information is digital. That digital means in the numbers, zeros and ones for a computer. So we can nowadays have developed different, you can say, image processing softwares by which we can basically we can automatically process these images, and automatically we can capture the information. Like this water body, this is a river. So I can just process this image and automatically capture this river part from this image. I can capture the building part, I can capture the road part automatically. Okay, so just imagine that sitting in your office, okay, you are preparing a live map, okay, and this is giving you the overall contextual information. Means like in conventional surveying, we used to do the surveying for a particular given object, okay, and we are not bothered to capture the data of other surroundings, but here you are getting everything. So this information is more accurate. Okay, you can get, in addition to planimetric positions, you can get biophysical variable information as well. That is helpful in variety of applications. Like these are some example of remote sensing images. Okay, as I said, the different sensors in different resolutions. Okay, this is like even from the stereo images, you can generate the 3D. So it means you can generate the 3-dimensional surface. So tomorrow you need not to go into field and do the leveling. Simply by using these stereo images, process them and generate 3D profile of a surface, then you can plan your infrastructure things. So this is a digital elevation model, okay, that is prepared from the stereo images. So on a elevation surface, basically satellite image is trapped, so you can just have a feel of real topography. Now you can do the planning, you can do the lot of cut and fill analysis, okay, on such a surface. So these images, I am using the word image. Image is nothing but a rectangular array of pixels, just like a photograph. आपने देखा होगा photograph, and each pixel element is having a number, and that number is representing reflected radiations, amount of reflected radiations. And generally we capture the data in multiple wavelength bands. Okay, like this is blue band, blue portion of the solar spectrum, green, red, near infrared, thermal infrared, middle infrared. So we used to capture the data in different wavelengths because the radiations in a particular wavelength, they are sensitive to a particular phenomena. So to study a particular phenomena, we try to capture the data in particular wavelength. So if we capture the data in multiple wavelengths, that is called multispectral data. And if we are capturing the data in single band, then it is called monochromatic data. When we capture the data in very large number of, you can say, wavelength channels, it is called hyperspectral data. And these remote sensing images, they have different type of resolutions. Radiometric resolution, that I was saying that how many number of differences a system is capable to record. So your remote sensing instrument is capable in recording the how many number of differences in reflectance. Okay, so that is called radiometric resolution, and it is expressed in terms of bits: 8-bit, 9-bit, 10-bit. Okay, so bit means number of levels. So 8-bit data means we are recording 256 number of differences. Mind it that we don't have any technology by which you can record such a large differences. So this gives us digital power that we can collect the large variation in data sets, and that's why this is very useful. This is the spatial resolution. Spatial resolution is that how from a particular dimension on the Earth surface, a particular area on the surface, we are collecting the data. So minimum area from where individually we are collecting the data from a surface, that is called spatial resolution. And nowadays we have the remote sensing data sets from 0.25 meter resolution to kilometer resolution. So we have a variety of options, and we can choose an appropriate data set for a particular appropriate application. Okay, so remote sensing also, it is subjected to a variety of possible errors, but nowadays we have developed methods, tools, and techniques that we can deal with those errors. This is particularly how we can process the remote sensing image. First of all, we conceptualize a particular application or particular problem. Then we try to identify suitable data sets. Then using appropriate technologies, we collect the data. Then data is basically pre-processed, okay, and then post-process, and then required information is extracted, okay, and then we can use the different information. So these are the different, you can say, the options, like hypothesis creation, measurement of, we have the different data collection techniques, we have different image processing solutions, and then we have different analysis methods which can be used to solve the different problems. Okay, so the advantages, there are a variety of advantages are there with the remote sensing data sets, okay, which are, you can say, neglecting the disadvantages of conventional technologies, that you can capture the data of very large areas very fast, okay, you can capture the data of inaccessible areas like forest or border areas or Himalayas, or like if there is a natural disaster where nobody can go from, but from the satellites you can capture the data and information. And mind it that this information is georeferenced, means you are getting real world coordinates along with, so you can relate any point on an image with the rest of the world. So that is the advantage, because these satellites rotate in their orbit. So many satellites are available. So nowadays we are in a position to get the repetitive information about a particular phenomena. Just like in a flooded area, you want to monitor the flooded situation, that okay, flood situation is worsening or it is improving. Okay, so you want to capture the data of that whole area daily. So that is possible nowadays from the satellites. That will not be that was not possible with the help of conventional technology. As I said, that we can capture the data in multiple band, multispectral remote sensing, very large number of band, hyperspectral remote sensing, okay, and ultra remote sensing, that is basically hundreds of bands. These are the some of, you can say, remote sensing programs. Like Landsat was the first remote sensing program or series of satellites that is launched by the US. They were the first one. 1972 was the first satellite was launched. Okay, and this MSS, TM, ETM, they are name of sensors. Then these are other type of remote sensing programs. Like Landsat 8 is the current satellite which is giving us the data. Okay, there are two sensors, OLI and TIRS on this particular satellite. We have our Indian remote sensing program. We are large family of even satellites in the space. The IRS satellites, IRS 1A, B, C, D, then ResourceSat 1, 2, 2A, then Cartosat 1, 2, 2A, B, C, D, and now Cartosat 3. Recently we have launched Cartosat 3. So variety of, you can say, satellites are available, and their sensors like LIS 1, LIS 2, that is the name of sensor, LIS 4, then in the Cartosat. So a lot of sensors are available. In the US, there are a lot of private companies are there which operates their own satellites, like space imaging or basically digital globe. Okay, they have the satellites of like QuickBird, WorldView 1, 2, 3. Okay, they are commercial operations. You can get the very high resolution data from these satellites. So nowadays, worldwide, variety of organizations, they are running their remote sensing programs, and the satellite data is available. Out of these, lot of data is freely available, and some are available at a certain cost. But of course, you can get the data. Okay, so this is Indian remote sensing program, and look at it. This is the history of, you can see chronological history of our remote sensing program. We were started in 1988 with the first satellite. Okay, LEAS 1, LEAS 2 were the sensor. Then IRIS 1A, B, 1C, 1D, resource sat. Okay, then basically Cartosat 1, Cartosat 2. Okay, resource sat 2. Okay, recently Cartosat 3 and 3A. So these are the family of, you can, satellites which are available, and from where we can get the data. Nowadays, from the remote sensing instruments, our country remote sensing instruments, you can get the data of up to 0.5 meter, half a meter resolution data can be obtained from the satellites. Means even you can count the number of people standing in a particular gathering from the satellites, and that data is georeference data set that you can get it. These are the specifications and wavelengths of ResourceSat 1, ResourceSat satellites, LEAS 4, LEAS 3, and WIPS. These are the name of sensors, and these are the wavelength bands. So due to limitation of time, I am not going into detail of it. Already it is, you can say, so these are few examples of our remote sensing products. Like this is a Cartosat 2 image of Bangalore city. Just look at it, how information rich this. You can, like, this is a like landslides. You can monitor this landslides. You can see this is the 3D of Himalayas. You can see the snow lakes. Okay, this is the Brahmaputra floods. So this dark blue line is a river, and this whole white area is submerged area. So you can determine the flood extent as well. The Cartosat 2 image. Then this is 2D. This is 2D image. Cartosat 2D. So look at it. Even you can determine the area of each building. And mind it, this is with the coordinates. So you can measure areas, volume, distances, anything. You can do it. Okay. ResourceSat 2 LEAS 4 image. Like this is from Cartosat 1. This is a 3D film generated from stereo images. Okay. This is Landsat program history. Currently, Landsat 8 is operational, and OLI and this TIRS, these are the two sensors. The OLI operates in 9 bands, and this operates in 2 bands. These thermal bands are used to determine the temperature, Earth surface temperature. Means on the Earth surface, any location, you can determine the Earth surface temperature. Even these satellites can be used to measure the soil moisture. Okay, so nowadays we start using them in estimation of evapotranspiration, and that can be used for optimum irrigation scheduling. So for very large areas, we people are nowadays using these satellites. So this is advanced land imager, ALI, very high resolution image from foreign satellites. These are the Landsat data products. Anyway, this is the vegetation map. Okay, this green is vegetation, this red is vegetation. You can determine this is the elevation model. So a lot of, you can determine slope, you can determine the direction of slope, you can determine the flow directions. So a lot of applications you can do from the satellites. This MODI is another remote sensing program from the NASA that gives us data free of cost, but for regional applications. It gives us the data at a 250 meter resolution to 1 kilometer distance, but the swath width is very large, 2,330 kilometers. Means our whole country, almost whole country can be captured in one go. So look at it, means daily you can get the data of any part of world. This is SPOT, the French remote sensing program, and you can get the data, very good data from SPOT program also. Now Landsat 7, this SPOT 7 is operational presently, and this satellite was launched from our own rocket, that is PSLV from our country. This is HR high resolution satellite, French. This is Iconos. So these are the satellites from private domain, WorldView 4. So you can get the data at a 30 centimeter resolution. So you can get the data at a 30 centimeter resolution, means you can identify each and every object which is having the size more than 30 centimeter on ground with the help of these satellites. So this is the ICONOS data. Just look at it. Like this is airport data. So even you can count the number of compartments in a baggage trolley. Okay, like this is stadium, Worldview 3. Okay, these are another ESA satellites, another European Union satellites, that is a Sentinel remote sensing program. From this also you can get the data free of cost. Okay, temperature data, thermal data, and optical data also at a 10 meter resolution. These are some of Landsat 8 satellite images, OLI. So I'm just moving quickly due to paucity of time. Hyperspectral images, you can, like Iris is the freely available data from where you can get the data in 240 channels. These are the typical application for remote sensing. You can use in urbanization, transportation, you can use in agriculture, crop health analysis, precision agriculture, compliance mapping, insurance, okay, updating road maps, wetland delineations, for natural resource management. This is very useful. You can get the extent of habitat analysis, you can do the hydrological analysis, geomorphology, zoology, so land use, land cover. So a lot of applications are there. You can determine the Earth surface temperature as well. Okay, you can do the lot of, you can say, hydrological analysis, climate related studies. You can determine the water pollution. Okay, like this red difference in color is indicating the water pollution in river. Okay, you can do the lot of ocean related studies. And these are the different biophysical variables which can be extracted from remote sensing data set, like location, elevation information, okay, then vegetation information like pigment in vegetation, LAI, leaf area index, evapotranspiration, surface temperature of land, water and atmosphere. You can determine soil moisture, you can use it for mineral composition estimation, hyperthermal surface roughness. You can determine a lot of air pollution related things from the atmosphere like aerosols, ozone concentration, water vapor, precipitation. Okay, so these are the typical biophysical variables, and these are the different solutions which satellite can be used for which type of application. Land use, land cover things you can obtain from different satellites, vegetation. Okay, and this is the suitability of different remote sensing programs. Like for response emergency, you need to use the high resolution images. Agriculture, you can use ICONOS, Spot, IRIS images. Crop yield estimation, you can use the Aster, MODIS, WAVES. So different type of suitability of the data sets in the satellite program is visible here. I'm sorry that I'm rushing because time is less and it's a huge topic. So at any stage, I can stop the presentation and we can have some question answer if you would like. So these are the drone, another technologies nowadays coming up, very high resolution images and three-dimensional data we can get from drone images to the drone survey. Okay, like the process is you fly the drone, you acquire the data, then remove the errors, process, and then you can determine you can output can be PDF, JPG, TIFF, or GIS format, save file, XYZ coordinates. And these are the different type of images you can get from your drones. You can get the 3D data, three-dimensional data. You can determine the canopy cover. Okay, what is, you can say, ground coverage from the plants. You can determine the elevation information. Digital elevation model means what is the ground elevation at different points. That is called digital elevation model. We can generate the 3D landscape, okay, at a very high resolution from few centimeter, 3 centimeter to meters. Okay, you can collect the data from drones at a 3 centimeter spatial resolution, means you can identify the objects up to 3 centimeter dimension on the surface. Okay, they are having a lot of applications like for mining, for hydrological applications, for urban applications. Like nowadays, we people are doing a lot of, you can say, projects for zonal, you can say, development of zonal development plans for urban areas, and we are using extensively drone images and GIS for planning of, you can say, infrastructure facilities. This is a drone image of urban area, that is seeker. So just look at it. You can make a measurement because this is a georeference image. So you can measure areas, width, length, okay? Even you can determine the plants, type of plants, everything can be captured and measured from these images. Then GPR, this is very interesting. Whatever we are discussing so far, they are about capturing the data from top. From means the capturing of data about a surface. But a lot of data, subsurface data is required. So nowadays we also have the solution to capture the subsurface data using ground penetrating radar. So subsurface information up to a certain extent, say 20 meter, 30 meter depth, you can capture the different type of information about the geological formations, about soil, different type of utilities which are buried inside the soil. You can get three-dimensional position of those utilities from GPRs. So this is a sort of like scanning, like X-ray of human body. So simply this is a sort of X-ray of ground. So through the X-ray of ground, you can capture the information, three-dimensional information of utilities, what is inside the soil, and what are the different type of soils, depth of soil, rock formations, okay? And indirectly you can get the information about, you can see minerals, okay, different type of minerals. You can obtain the diameter of pipes, cables, which are running underground, okay? And these are basically, this is nothing but similar to remote sensing, and this is ground penetrating radar. It works based on the microwave electromagnetic radiations, means your instrument emit the radiations. Those microwave radiations, they are going inside the ground, okay? They interact with the different objects, soil, and again reflected back, and the reflected radiation, they are captured by the instrument. And with the help of those you can capture the information, okay? We prepared basically maps, three-dimensional maps, okay? Like this, you can get soil sampling, okay, through the sensors. You can use from the radars. They are in non-invasive, means you are not disturbing the soil sample. If you are physically you are capturing the samples, then you are disturbing sample. But from the GPR, you can get the data without you can say disturbing it. So you can get the data real-time mapping. You can determine the root zone characteristics. You can determine the soil profile from the depth, okay? It is using again microwave remote sensing portion, this portion of wavelength in GPR. And this is just an example from the top, okay? It emits basically radiation in microwave portion of remote sensing. These radiations travels inside Earth surface. They interact with the different type of materials and reflected back. It is again recorded by the same instrument, okay? And based on the relative difference in reflected part of these radiations, we try to capture what is what at what distance it is, okay? Like this is the example. So see, this is a real world example. This is the sand layer. This is the scan map of, so this is sand, this is clay layer. Yahan dekh rahe hain paas mein. So just compare the things that you can get. These are the layers, okay? So you are getting the clay layer, upar sand hai, and below is different type of things. Even you can get the like utilities. If you are scanning at what depth, what is available below the surface, you can determine it, okay? Like this is the scanning of road. So you can get where concrete is deteriorated, where is the pipeline, what is the diameter of that pipeline. Everything can be captured in 3 dimensional X, Y, and Z. And mind it, nowadays we have developed the softwares where the data, 3-dimensional data that is captured from GPR, from UAVs, drones, Lidar, or satellites, all they can be integrated in GIS for the solution of different particular problems. In the archaeology, it is very helpful. Like you can determine the changes in thickness or change in density of the different materials, so you can have an idea about the composition of different materials. You can use for soil moisture mapping in high areas. Then there is another, you can say option, ground-based, you can say Lidar. Lidar is somewhat similar to drone. Okay, there is a radar-based and it works in microwave portion or remote sensing, and it captures the very high resolution 3-dimensional data. Okay, we can capture basically the data about the distance again, it is working on the same principle as your remote sensing instruments or your satellites. Basically, it emits the radiations. Those radiations are emitted from the lidar that is mounted on a moving aircraft. So those radiations coming on the ground, interacting with the surface, going back, that is captured by the lidar, and the time of travel of these radiations is measured, and based on that we can calculate the distance, and from the distance, from the multiple points, multiple times, if we measure these distances, we can triangulate it and we can determine the three-dimensional information. So the lidars are, nowadays we people are using large scale high resolution mapping. Okay, so this is lidar. It is somewhat different than photogrammetry. Okay, in the photogrammetry we used to make the measurements of photograph, but here we can extract the three-dimensional data, very high resolution data from this. And you can put this lidar on aircrafts, you can put it on satellites, you can put it on raised platforms as well. And you can get the data at very high resolution, like less than 5 meter resolution. You can get the data you can intensity of these pulses also. You can determine the vegetation information and other type of variables. So these are the different data products which can be obtained from lidar. Like DMs, you can generate DMs, you can generate terrain models, you can generate tints, you can generate contour maps, photographs, slope map, aspect map, relief map. So all type of topographical information can be obtained from lidar. So these are the two examples. Like this is a forest study. So depending upon the difference in this pulse intensity, we can differentiate the plant health or density of the plants. Okay. So similarly, variety of applications are there, like this the lidar data. Okay. Then there's another solution nowadays is available to again capture the three-dimensional data, that is terrestrial laser scanners. Imagine that you want to make a 3D copy of yourself. So scan yourself from a laser scanner. It gives you in millimeter accuracy or three-dimensional position, means your digital copy can be created from terrestrial laser scanner. So this is very useful in capturing the data, very high resolution data about different type of objects. Like you can put a laser scanner on your moving car and you move along a road, and three-dimensional profile of a road can be captured okay, readily. And three-dimensional position means X, Y, and Z. Okay, that like you can get what is the thickness of your footpath, okay, curved stone, what is the diameter of your electric pole, light pole. So very minute detail in millimeter accuracy you can get it. Like if you scan a building, so even you can determine the millimeter dimension of a jali in a window. So very accurate, three-dimensional also, and in global coordinates also. Again, this works on the same application based on the lidar that we people are working. So laser scanner, it uses the laser technology, and it basically determine a point cloud, means thousands, millions of point observations are made from a surface, and each point means a three-dimensional you can say position. So when you scan a surface, millions of three-dimensional points are calculated. That is called point cloud. And when you drop a photograph on this, you have a very high resolution image, a three-dimensional image. Okay, so just like see this example. Okay, so this is everything is three-dimensional, X, Y, and Z location. So you are obtaining basically what is diameter of these poles, okay, trees, how many number of trees, grass, you can determine their areas, you can determine their height. So everything three-dimensional information is available, and in terms of the point cloud, and millions of points are there. So it gives us power to process these points to generate an output at a required resolution. Okay, so these are the typical, like capturing the data from a scanner, it will generate such a surface, and just look at it. This is a 3D copy, three-dimensional data of point cloud of a object, a building. So how like alive this information is. So nowadays you can preserve the monuments. You can make a 3D of monuments and you can store it. So later on, while you're doing the restoration work, you can measure accurate dimensions. Okay, like you can tunneling. Okay, you can this is the 3D dimensional laser scanner data. Okay, like this. So you can capture the data. Like these are the three-dimensional you can say scans. of different objects and things. This is arches, castle, please. Okay, so these are the technologies. What we discuss is they are data collection technologies, and these technologies can be used to process using a variety of image processing softwares. So we have a variety of softwares where these data sets can be kept processed, and a variety of information can be extracted digitally. So we are not processing them manually, digitally, because your data is digital. It is available in the form of you can say numbers. So a lot of mathematics, variety of image processing techniques can be applied. A variety of information can be extracted from data sets. So these are the typical, you can say, softwares. I'm just going through. These are the different softwares which are available for the processing of these data sets. Okay, and most, you can say, use these softwares are NV, Ecognition, ADAS Imaging, okay, ArcGIS, this ADAS Imaging. So these are the name of the different softwares which we people are using for the processing of these images. These are the maps, okay. And another is GIS, wherever all these data sets captured, information is captured from the different sources, the data, or you can say information that is available in different formats, different scale, okay, that can brought into a common standard in GIS. So GIS is a big data analytics sort of technique where it stores very large volume of data sets, okay, and uniform standards. You can do a lot of variety of, you can say, analysis of data set. You can retrieve the information which satisfy a certain condition from the large volume data sets. Okay, you can apply a lot of mathematics, you can do the lot of analysis, and you can generate the lot of outputs. So this is GIS is nothing but geography and information science, is nothing but it creates your earth surface in digital domain. Okay, so we are converting real world into digital world in GIS. Okay, and we capture the data, geospatial data, the whole real world in terms of geospatial data, point, line, polygons, okay, in terms of the geometries, and their characteristics are assigned as a attribute data along with those geometries, and then we can apply different type of, you can say, operations on those geometries for the solution of different things. So GIS complete, it acquires the data, we can compile, we can store the large volume data. Updation is very easy. You can apply a lot of manipulation techniques, analysis techniques, and you can generate outputs. So GIS is very huge. You can use it, your data, you can use the big data analytics, data mining things, okay, to analyze the data. You can do the lot of analysis, site selection things. You can extract the different information. I can give you an example, simple example. I suppose you have a digital data of, say, land holding of whole country, and suppose government of India is decided to identify the beneficiaries, okay, and the condition of to identify the beneficiaries is that beneficiary should be one who is having land holding less than 2 hectares. So imagine that conversely, using revenue records, how many number of years will be required to extract that information. But if the same information is available in GIS, if in the all Kasara maps, they are converted into GIS databases, into digital domain, then identifying the beneficiaries of analyzing the billions of Kasara records, it's a matter of seconds. That in seconds you can generate a Excel list, okay, where your beneficiary list that satisfy your own, you can see, condition can be extracted from the large volume data set. So that is big data analytics, and the GIS giving us capability to store large geospatial data. We can manipulate it, we can update it in the digital domain, and you can perform a lot of, you can say, applications to generate solutions for the different problems. So I'm sorry that I'm not going into detail of this because this requires time. So I'm just giving you the overview so that you can have an idea that what are the potential applications. So here real world is converted into digital one. Each and every aspect on the surface is converted into geometries, and these geometries are point, line, polygons, and their related characteristics, they are stored in tables, and those tables are attached with those geometries. So your and GIS, beauty with the GIS is it also stores the relationship. Like if there's a road is going on and a particular building is on left side. So what is the relationship geometrically between road and building? That also relationships are also stored in GIS. That's why you can determine that how, okay, you can determine in Jaipur district, okay, in a particular X village, in which are the villages which have population more than 1,000 and where their, you can say literacy rate is more than 70. So just imagine that you are searching the data set, you are relating the boundaries of district and then village, and then you are looking into your literacy data and your population data, and then you are only identifying, you're only extracting that information that is satisfying your query or your condition. That can be captured, that can be, you can say, captured in the form of a map. You can generate a map of those villages and you can generate the output into your in terms of the tables. So that is the power of computer, the power of digital analysis or big data analytics in GIS, that you can do a lot of analytics on data, geospatial data, and you can perform complex queries. You can solve the different environmental resource planning related problems. And the typical problems of GIS are like for facility management, like selection of, you can see alignments of roads, selection of canal alignments, selection of water harvesting structures, selection of location of the school, selection of, you can see health facilities, okay, identifying the gaps in the health facilities. You will surprise to know that now a government of India made mandatory to use the GIS in Amrut scheme. Probably you are familiar with that. To determine, first of all, you need to create a GIS of facilities in urban areas, then try to identify which are the gaps in water supply sanitation, okay, on GIS, because there are a lot of duplications. Nobody knows that where is the pipeline is going on, when the work was done, which area is left out and which is not. Such data is not available. So once such an information is available on GIS, everything is in coordinates, in terms of the coordinates, and at the mouse of the click, you can determine the different facilities, where it is located, where it is not located. There is no, you can say, problem of data coordination, communication between things. So that is the huge, and that's why it is very helpful in site selection for any type of structure or facility. It is very helpful in environment impact assessment, disaster monitoring, management, because variety of informations you can overlay together, number of, you can see, information that is available in different domains, and that information, when it is attached with a coordinate, so variety of information that is relevant to one particular coordinate can be integrated. So the overlay of information can be performed very easily, and you can do the site selection or do the decisions, okay, by referring the data or information of different locations across the number of hundreds of information layers. Okay, it is a lot of application in like natural disaster management. This is a Kedarnath tragedy. You must be knowing that in 2011 there was a tragedy, flash floods in Kedarnath. So this is typical. Just look at it again, geospatial data, and how this was the Kedarnath. At number 1 point is the Kedarnath, and it was washed out, and you can determine that how it was washed out, how much area is getting affected from it. Like this is the Kedarnath, and how the, you can say, water that is gushed down from the heights, and this is basically nothing but it washed out. The whole town was washed out due to these floods. These are the images of that time of Kedarnath floods, and see the situation. That these are the satellite images. So how this is the Kedarnath temple. Okay, this is alive when there is no flood, and after this is the flood. This was the so damaged, and mind it, during this disaster, this is a typical example that how the geospatial technologies are helpful, because at that time all the roads, they are washed away. There are a lot of incident of landslides. We were not knowing that where people are trapped, so we have used extensively the drones, satellite images, okay, to track and trap the where people are, you can say, stranded. So using the helicopters, then we picked up. So just look at it. This is the inaccessible, means geospatial data that is collected in case of difficulties. This is Kedarnath again. This is the floods. How you can basically determine the floods? आप देख रहे हैं, this is nothing but in a water. This is a pollution, means some oil spill in sea. So even how much area of sea is basically affected by oil also can be captured from the satellite images. Okay, like forest fire. So you can locate the forest fire, how the forest fire is proceeding, in which direction it is moving. All those things can be captured from geospatial data things. And this is a image in case of disaster or like earthquake. Okay, we can plan the evacuation. Okay, we can determine the rehabilitation centers, and we can provide. This is volcanic eruptions. This red color is lava, nothing but the lava. Okay, how it is moving, in which direction lava is flowing. All those things can be determined. We can determine the extent of losses due to tsunamis. Okay, like in 2005, the tsunami in the Indian coast. Okay, at that time our Indian satellite were not in the sky, so we have used the data of some other satellite, and we are able to, in hours, in a matter of hour, we are in a position to determine that, okay, what was the extent of, you can say, damage. The hurricanes, you can monitor the direction propagation of hurricanes. Okay, you can monitor the landslides. We can determine the flood extents. Like this is the flooding area. So from the satellite images, you can determine the exact area and how much properties are getting affected, or how much area is drowned. So all those things can be captured in 3 dimensions. Okay, this is again, so in the for natural disasters, this is very helpful. Okay, so benefit with the GIS, geospatial data are better maintained in digital format. They can be updated easily. Revisions updating are very fast. Okay, you can do the lot of search, and you can extract the data, any type of data that is satisfying your requirement very efficiently. Okay, you can share the data because data is stored digitally, so you can preserve it, you can save, you can share very easily. It helps us because in GIS your data is stored in database management systems, so concurrent use is possible, means the same data can be used by multiple peoples. That is possible in case of GIS, which was not in conventional technologies. So that is all from my side. Thank you. I have taken a lot of time, and thank you very much for patient listening. If you any you can say query, okay, you are welcome. So any questions, please? Any questions, please? There's few questions are coming up. Any website giving cartosat images? Yeah, means cartosat images of all areas, they may not be available, but there's a ISRO's platform, okay, that is Bhuvan. So on the Bhuvan platform, you can have some data free of cost. Okay, even from the NRSC website and data archives of NRSA, okay, and data archives of NASA, you can obtain certain images, okay, certain data sets free of cost. There are few programs from where we can get the data free of cost. For cartosat images, there's a restriction as the resolution increases. You see, all the programs, they are pre-designed. They're designed for fixed specifications. Like from the Cartosat 2E, 2D, and 3, you can get the data in monochromatic mode up to the 30 centimeter. Okay, there are like worldview 4 data sets. No, it is actual. This is not a theory. You can verify it. Okay, it is not. It is actual data set. You can get it. I just shown you in the presentation a real example we have captured from the drone images. Its resolution is 10 centimeter, and we people are using 30 centimeter data. That is worldview data. A lot of data we people are using. So actually, whatever I said is it is true. There is no theory. Basically, it's a practical things. Okay, so some data sets are available free of cost from like NASA. There's their portal, that Earth Explorer. So simply you log in yourself, you create your login credentials, and then simply you can download the data. Similarly, from the Sentinel, you can see satellites, European Remote Sensing Program, you can get the data free of cost in 10-meter spatial resolution. Okay, but the data that is 30 centimeter data, it is available with a cost. Okay, from ISRO also, the data is available at very nominal cost. Is there any application of topology in these images? Yes, of course. Without topology, how we can establish geometric relationship between the different objects? So GIS, basically the spatial data is the thing that we people are using the spatial data about the different objects and phenomena and their interrelationships as well. So topological rules are always embedded in your GIS databases, and we use extensively topological rules, okay, in solution of different geographical problems. This was another question. Is it feasible to teach students about geospatial data collection? Yeah, definitely. We people, like in my institute, we people are running programs. Like in UG level, there's a elective course, and PG level for water resources, engineering students, and other students, we teach it in PG level program.
Mahesh sir, you are muted, sir.
Oh, sorry. I'm sorry. So I need to again answer the questions.
Yes, sir. Yes, sir.
Thank you for pointing out. So question is, which software can be used for training students? You see, and I was saying that the softwares are available in public domain as well as in commercial domain. So like ILWIS, ILWIS, ILWIS is a software which have both capabilities, image processing as well as basically GIS capabilities, and it is available free of cost. For GIS, basically quantum, QGIS from the quantum is also available, that is free of cost. GRASS is another software that is available free of cost. Okay, so students can be taught, and of course these courses can be taught in laboratory classes, and we people are teaching them. Any other question, please? If I missed, please ask another question. For water quality, I said that for water quality, basically certain wavelengths are very sensitive, okay, to the water quality pollutants. So if we capture the data in those wavelengths, okay, and when the reflected radiation, they are correlated with the you can say data, quality data. Of course, we can develop some algorithm, and that can be determined. Water quality can be determined. Any other question, please? Okay, so thank you very much for patient listening, and anybody, they are welcome for further queries. Okay, and I can share definitely some information and a lot of other material and literature as well. So my mail address is available on the first page of the presentation. And again, my mail address is mkjat. I'm just typing on this my mail address. Please, you can contact me. Okay, thank you very much.